Pluto has always been a mysterious and intriguing object in our solar system, a planet once considered a major member of our planetary family, but later demoted to dwarf planet status due to its unusual orbit. Despite this reclassification, Pluto continues to capture the imagination of astronomers and space enthusiasts alike. Recent reports suggest a potential encounter between Pluto and Neptune, raising concerns among scientists, including well-known figures like Neil deGrasse Tyson and Michio Kaku. But how did Pluto end up in such a peculiar orbit that brings it dangerously close to Neptune? And what could the possible collision between these celestial bodies mean for life on Earth? Pluto's unusual orbit and its relationship with Neptune. Pluto's journey around the Sun is anything but ordinary. Unlike the other planets in our solar system, Pluto follows an elliptical, oval-shaped orbit that varies dramatically in its distance from the Sun. At its closest, Pluto comes within about 30 astronomical units, AU, of the Sun, but at its farthest, it reaches more than 49 Australian dollars, twice the distance of Neptune from the Sun. In addition to its elongated orbit, Pluto's path is tilted by about 17 degrees from the ecliptic plane, the flat plane in which most planets orbit the Sun, further adding to the complexity of its orbit. These unusual characteristics make Pluto a perplexing object in our solar system. One particularly intriguing aspect of Pluto's orbit is its crossing of Neptune's orbit. For about 20 years in each of their orbits, Pluto's path brings it closer to the Sun than Neptune. Despite the apparent risk of a collision, the two bodies never crash. This raises the question, how do Pluto and Neptune avoid a catastrophic encounter? The answer lies in the gravitational interaction between the two planets. As Pluto and Neptune approach each other, their orbits are influenced by their mutual gravitational pull. However, the dynamics are such that Pluto and Neptune are always 90 degrees apart when their orbits intersect, a phenomenon known as resonance. This orbital dance ensures that while their paths cross, they never collide. The two planets' orbits are in a stable configuration that keeps them from crashing into each other, despite their proximity. The stability of Pluto's orbit. Pluto's orbit may appear chaotic at first glance, but it is remarkably stable over long periods. Astronomers have been able to track Pluto's movements with great precision, and simulations have shown that even though its orbit is irregular, it remains predictable over millions of years. The stability of Pluto's orbit is partly due to the influence of other planets in the solar system, which help to stabilize its path. For example, Neptune's gravitational pull ensures that Pluto's orbit remains in a steady state, preventing it from veering off course in a way that could lead to a collision. However, scientists are still concerned about the long-term stability of Pluto's orbit. Even small changes in its velocity or position could have significant consequences over time. To better understand how these changes might affect Pluto's orbit, researchers use advanced simulations to model its movement through space. These simulations allow astronomers to test how slight alterations in Pluto's orbit could influence its interactions with other planets, particularly Neptune. Despite the potential for minor disturbances, Pluto's orbit has remained stable for billions of years, suggesting that even with its erratic characteristics, the planet follows a predictable pattern. This insight is crucial for understanding the overall dynamics of our solar system and how different celestial bodies interact with each other. What if Pluto and Neptune collide? While the likelihood of a direct collision between Pluto and Neptune is extremely low, scientists cannot completely rule it out. Over time, even the smallest changes in the orbits of these planets could lead to a scenario where their paths intersect in a way that results in a collision. However, such an event would take millions or even billions of years to unfold, and the odds of it happening in the near future are virtually non-existent. That being said, the possibility of a collision raises important questions about the stability of our solar system. If Pluto were to collide with Neptune, the impact could have far-reaching consequences, potentially affecting the orbits of other planets in the solar system and even altering the dynamics of the entire system. Such a catastrophic event could lead to dramatic changes in the solar system's structure, but the likelihood of this occurring in the foreseeable future remains exceedingly small. Why Pluto remains fascinating. Despite its small size and distant location, Pluto continues to captivate scientists and the public. Its unusual orbit and the possibility of a future encounter with Neptune make it an object of great interest in the field of astronomy. Pluto's status as a dwarf planet has not diminished its importance in the study of our solar system, and its interactions with Neptune offer valuable insights into the complex gravitational dynamics that govern planetary orbits. In recent years, advancements in observational technology have allowed astronomers to study Pluto and its orbit in greater detail. These discoveries have helped to deepen our understanding of the solar system's outer reaches, revealing the intricate relationships between planets, moons, and other celestial bodies. Conclusion: Pluto's orbit, crossing that of Neptune and exhibiting an unpredictable nature, continues to intrigue and challenge astronomers. Despite its small size and distant location, Pluto plays a significant role in our understanding of the solar system. While the likelihood of a collision with Neptune remains low, the possibility cannot be completely ruled out, and scientists continue to monitor the situation with great interest. The gravitational dance between Pluto and Neptune highlights the complexity and interconnectedness of our solar system, reminding us that even the smallest celestial bodies can have a profound impact on the cosmic order.
The study of orbital elements of celestial bodies like Pluto plays a crucial role in improving future space missions. By analyzing the orbits of planets, we can help design safer routes through the solar system, anticipate potential hazards, and plan missions to distant regions of our vast universe. Kaku emphasizes that insights gained from Pluto's orbit can be applied to exploring other celestial objects, offering a roadmap for understanding far-off worlds. He often highlights the deep connection between celestial mechanics and theoretical physics, pointing out that the movements and interactions of planets, such as the gravitational relationship between Pluto and Neptune, are rooted in fundamental laws of physics. Kaku's work in theoretical physics, especially string theory, aims to unravel these principles at their core. He suggests that focusing on the complexities of celestial mechanics, such as Pluto's orbit, can provide valuable insights into the fundamental laws governing the universe. Like Tyson, Kaku has also considered the potential impact of celestial bodies, relating it to his theories about the cosmos. A collision between Pluto and Neptune, while significant in cosmology, could offer a unique observational opportunity, contributing to our understanding of string theory. String theory, which replaces point-like particles with one-dimensional strings, seeks to explain the fundamental forces and matter in the universe. Such an impact could generate extreme states of energy and gravity, shedding light on the behavior of elementary particles and forces under extreme conditions. The gravitational waves produced by such a collision could offer crucial data for testing predictions of string theory, especially concerning spacetime. While the direct impact on Earth would be minimal due to our distance from the outer solar system, the scientific implications could be profound. Understanding events like this could deepen our interest in the fundamental nature of the universe as described by string theory and other branches of theoretical physics. The unique characteristics of celestial bodies, influenced by the gravitational forces of nearby planets, particularly Neptune, highlight the intricate and dynamic nature of space. While the universe holds many mysteries, the three-body problem is just one example. Scientists anticipate other potential cosmic catastrophes, underscoring the ongoing quest for understanding and exploration in the vast expanse of the universe. Although planetary collisions are highly unlikely, there remains a small possibility that planets could cross paths in space. This can occur because the paths of planets are influenced by various factors, such as the gravity of other planets, a phenomenon known as the three-body problem. In systems like TRAPPIST-1, where 7 Earth-sized planets exist, gravitational forces create a sort of dance, affecting how the planets move. Orbital resonances over time can destabilize a planet's orbit, potentially leading to collisions. Although planets in systems like TRAPPIST-1 are interacting, collisions are not happening at present. Scientists monitor these systems to understand how planets influence each other's orbits, especially when they come into close proximity. This research helps us comprehend how planets move through space. Occasionally, there are rogue planets that don't orbit a star and instead float aimlessly through space. These planets were once part of a star system but were ejected due to gravitational forces or close encounters with other stars. Over time, These wandering planets may travel vast distances and could eventually encounter other star systems. However, since space is mostly empty, the chance of these rogue planets colliding with another planet is extremely low. Rogue planets are fascinating because, compared to the number of stars and planets with stable orbits, the chances of a collision remain minuscule. When galaxies collide, the orbits of the star systems within them can be disrupted. While planets are unlikely to directly collide during such massive events, gravitational interactions can alter the movements of stars and planets. Some planets may be flung into space, becoming rogue planets, while others might collide with nearby stars. These disruptions can potentially create new celestial bodies or even form new stars. The late heavy bombardment theory suggests that, around 4 billion years ago, there was a period of intense impacts, including comets and asteroids. This bombardment is thought to have occurred due to the movement of outer planets like Jupiter and Saturn, which disturbed the orbits of smaller objects in space. As a result, these objects were thrown onto irregular paths, with many ending up in the inner solar system. This led to a dramatic increase in collisions on planets like Earth. Although these impacts did not involve direct planetary collisions, they demonstrated how gravity can cause significant changes in the motion of celestial bodies. This period of bombardment played a role in shaping the surfaces and history of planets in our solar system, and may have even contributed to the arrival of water and organic material on Earth, which was crucial for the development of life on our planet. The balance of gravitational forces and the movement of objects in space are essential for expanding our understanding of the universe and our place within it. As we explore space, we encounter many peculiarities, and Pluto's orbit serves as a fascinating example of such complexities. Unlike the nearly circular orbits of most planets, Pluto's orbit is highly elliptical, meaning it isn't a perfect circle. At certain times, Pluto even comes closer to the Sun than Neptune does. This creates an interesting scenario, as Neptune is also orbiting the Sun, and there's a small chance that Pluto and Neptune could collide. However, despite their orbits crossing paths, the two bodies don't crash into each other most of the time. This is due to the influence of gravitational forces. Gravity acts like an invisible force, pulling objects towards one another. While Pluto and Neptune might seem on a collision course, their orbits are delicately balanced, influenced by gravity's pull. Pluto's unusual orbit reminds us that space is full of surprises, and what may appear chaotic at first glance could actually be a finely tuned balance of forces. Studying Pluto's orbit gives scientists valuable insights into the intricate mechanics of our solar system. Ongoing observation and exploration are crucial for deepening our knowledge of the universe. Imagine if Pluto and Neptune did collide. It would be a momentous event that could shake our understanding of the solar system. While we've made progress in comprehending space, the current situation shows that there's still much we don't know. By focusing on the impact of large planets on Pluto's orbit, scientists can learn more about how the entire solar system functions. The movement of each planet has a ripple effect, influencing the paths of other objects in space. Although space is incredibly complex, some believe that a collision between Pluto and Neptune is still unlikely. Renowned astrophysicist Neil deGrasse Tyson has intriguing thoughts about Pluto. He suggests that reclassifying Pluto as a dwarf planet, rather than a major planet like Earth, is a step forward in our understanding. Tyson believes that we are continually learning new things about how objects move in space, and Pluto's erratic orbit is a reminder that there's much more to uncover. He finds the mysteries of space to be compelling and believes that events like Pluto's reclassification captivate people's interest in astronomy. Tyson aims to help people appreciate the fascinating and sometimes bizarre aspects of space, emphasizing that the study of space mechanics can be truly astonishing. Tyson also works with other researchers to raise awareness about the potential risks posed by Pluto's unusual orbit. Despite the seeming improbability of a collision with Neptune, the possibility of such an event happening one day is concerning. Tyson points out that a collision would release vast amounts of energy, and debris from the impact could scatter through space, potentially striking other planets or moons. Neptune itself could also experience a shift in its orbit as a result of such an impact. Theoretical physicist Michio Kaku, known for his contributions to string theory and science communication, offers a unique perspective on space exploration. He believes that understanding the future of space travel and the relationship between celestial mechanics and theoretical physics can be achieved by studying anomalies like Pluto's orbit. Kaku views Pluto's orbit as a window into the future of space exploration. By grasping the complexities of gravitational interactions, scientists can unlock deeper insights into the forces that shape the cosmos.